Welcome to Opulenta.ai. I am Opulenta. Today I want to talk about software development. Please feel free to pause the video and look up any words that you don't understand before continuing. Good morning, everyone, and welcome to week 1 of our course on software engineering principles. This week, we will be diving into the exciting world of collaborative coding. As software developers, it's essential for us to work effectively with others and comprehend their code. Therefore, we will explore various techniques that can minimize errors and avoid delays caused by misunderstandings among team members. Remember, being a software developer involves more than just writing code. Throughout this unit, we will cover several important topics. Let's take a look at what we have in store. We will start by exploring the 4 major programming paradigms: imperative, logical, functional, and object-oriented. We'll understand the characteristics of each paradigm and discuss which programming languages fall under which category. Additionally, we'll learn when to choose a particular programming paradigm based on the requirements of our projects. Next, we will survey the techniques for eliciting, modeling, and writing requirements. It's crucial to have a clear understanding of the needs and expectations of a software project. We will differentiate between functional and non-functional requirements and discuss why user stories alone cannot be considered as requirements. We'll also touch upon formal requirements modeling and its importance, despite it being less commonly used. We will emphasize the need for coding standards, source control, and proper code and project documentation. Writing clean code that adheres to a uniform standard is essential for maintaining code quality and facilitating collaboration. We'll discuss coding standards such as PEP and explore the role of tools that help enforce these standards. Additionally, we'll highlight the significance of good code documentation and touch upon major automated coding tools. We'll also delve into the importance of source control and how continuous integration ties in with it. We will introduce the concept of software libraries, virtual environments, and dependency management. Software libraries provide reusable code components that can enhance the functionality of our applications. We'll learn how to effectively use libraries within larger applications and even explore the process of building our own libraries. Furthermore, we'll gain a basic understanding of virtual environments and why we use them. Lastly, we'll discover the role of dependency control tools in managing dependencies within a virtual environment, and we'll see how this aspect aligns with project documentation. By the end of this unit, you will achieve the following learning outcomes. Understand the differences between the 4 programming paradigms and recognize which programming languages belong to each paradigm. You'll also develop the ability to choose the appropriate programming paradigm based on project requirements. Differentiate between functional and non-functional requirements and understand why user stories alone are not sufficient. Additionally, you'll gain a high-level understanding of formal requirements modeling and its significance. Comprehend how to validate requirements and track them throughout a project's life cycle. You'll also acquire an understanding of requirement elicitation techniques and how they tie in with requirement writing and modeling. We'll highlight why poor requirements gathering often leads to project failure. Recognize the importance of writing clean code that adheres to coding standards. You'll familiarize yourself with coding standards like PEP and explore the role of tools that help enforce these standards. Appreciate the need for effective code documentation and gain basic knowledge of major automated coding tools. Additionally, you'll understand the significance of source control and its integration with continuous integration. Understand the concept of software libraries and learn how to utilize them within larger applications. You'll also gain a foundational understanding of virtual environments and why they are employed in software development. Furthermore, you'll grasp the purpose and usage of dependency control tools and their role in managing dependencies within a virtual environment. We'll explore how these aspects tie in with project documentation. I hope you're all excited about this week's content. Let's embark on our journey into the world of collaborative coding and software engineering principles. Throughout this week, we will explore these topics in depth, engage in practical exercises, and discuss real-world examples to solidify our understanding. Remember, mastering these principles is crucial for your success as a software developer. So, let's dive right in and make the most out of week 1. Get ready to expand your knowledge and skills in collaborative coding and software engineering principles. Let's make this a productive and enlightening week together. Take some time now in your first exercise to look up and understand the following words. Software engineering principles. Collaborative coding. Programming paradigms. Imperative, logical, functional, object-oriented. Eliciting, modeling, and writing requirements. Coding standards. Source control. Code documentation. Software libraries. Virtual environments. Dependency management. Formal requirements modeling. Requirement validation. Requirement elicitation techniques. Clean code. PEP coding standards. Automated coding tools. Continuous integration. Open source libraries. Project documentation. To help you with each of these, I have included a provisional description. Compare your research to my first responses. Let me know in the chat whether you think they are correct or complete, and why. These definitions should help provide a better understanding of the key terms related to software engineering principles and collaborative coding. Here are the definitions for the key words. Software engineering principles, the fundamental concepts, methodologies, and practices used in the discipline of software engineering to design, develop, and maintain high-quality software systems. Collaborative coding, the practice of multiple developers working together on a software development project, sharing code, ideas, and responsibilities to achieve a common goal. Programming paradigms, different approaches or styles of programming that define how solutions to problems are formulated using programming languages. Examples include imperative, logical, functional, and object-oriented paradigms. Imperative, a programming paradigm that focuses on describing how a program should achieve its desired outcome by specifying a series of statements or commands to be executed sequentially. Logical, a programming paradigm that involves using formal logic to express and reason about computations and problem solving. Functional, a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state or mutable data. Object-oriented, a programming paradigm that organizes data and behavior into reusable structures called objects, which interact with each other through methods, encapsulation, and inheritance. Eliciting, modeling, and writing requirements, the process of identifying, understanding, documenting, and specifying the needs and expectations of stakeholders for a software system. It involves techniques such as interviews, surveys, and creating models or documents to capture requirements accurately. Coding standards, a set of guidelines and conventions that define a consistent style, formatting, and best practices for writing code. These standards promote readability, maintainability, and collaboration within a software development team. Source control, the practice of managing and tracking changes to source code files during software development. It allows multiple developers to work concurrently, maintain version history, and merge code changes efficiently. Code documentation, the process of creating supplementary documentation that explains the purpose, functionality, usage, and structure of code. It helps other developers understand and use the code effectively. Software libraries, pre-existing collections of reusable code modules or functions that provide specific functionalities, allowing developers to leverage existing code instead of reinventing the wheel. Virtual environments, isolated environments that allow developers to create and manage separate configurations of software dependencies, such as libraries and frameworks, for different projects. It helps maintain project-specific dependencies without conflicts. Dependency management, the process of handling and resolving software dependencies, which are external code components or libraries required by an application to function correctly. It involves managing versions, resolving conflicts, and ensuring compatibility. Formal requirements modeling, the practice of representing system requirements using formal notations or languages, such as UML, Unified Modeling Language, to create visual models that capture the structure, behavior, and relationships of system components. Requirement validation, the process of evaluating and verifying that the defined requirements accurately capture the needs of stakeholders and can be implemented effectively. Requirement elicitation techniques, various methods and approaches used to gather requirements from stakeholders, such as interviews, workshops, questionnaires, and observations. These techniques help extract information and clarify expectations. Clean code, well-structured and readable code that is easy to understand, modify, and maintain. Clean code follows coding standards, avoids redundancy, and employs best practices for software development. PEP coding standards. PEP stands for Python Enhancement Proposal. It is a set of guidelines and recommendations for writing Python code to promote consistency, readability, and maintainability within the Python community. Continuous integration, a development practice that involves frequently merging code changes from multiple developers into a shared repository. It enables early detection of integration issues, facilitates collaboration, and automates build and testing processes.
Please feel free to have a look at our website and go to the blog section to read more. www.opulenta.ai. Subscribe to our YouTube channel to keep up to date. If you would like any specific help, contact us on result@opulenta.ai. Thank you for watching. Bye.